Hi all, Alex B here with another question on electric power and resistance from chapter 25 of Giancali's Physics for Scientists and Engineers. So we're told that we have a hairdryer with two settings, one which is 850 watts and one which is 1250 watts. And we're first asked to make a guess for which setting has a lower resistance. So if you watched my last few videos, you remember that we saw that a lower resistance gave a higher power. This is assuming that we have a fixed voltage. So we're going to go ahead and make a guess that the 850 watt setting should have a higher resistance. But to be sure, we're going to go ahead and calculate it. So part B asks us first to calculate the resistance for the 850 watt setting. Again, if you watched my last two videos, you know that there's two equations that we need here. We need our trusty P is equal to IV, equation for power, and V is equal to IR, our Ohm's law. And we can combine those to find that P is equal to V squared over R. Or rewriting it, we can have R is equal to V squared over P. Plugging in the numbers that we have, R is going to be equal to 120 volts squared divided by 850 watts, which should give us about 17 ohms. For part C, we're doing the same calculation, only this time with the 1250 watt setting. So we have 120 volts squared divided by 1250 watts, and this time we find that our resistance is about 12 ohms. Where here I'm using two significant figures everywhere because the problem gave us two significant figures. And we see that just as we guessed, it was actually the lower power setting had the higher resistance, whereas the higher power setting actually had a lower resistance.